Hello Leopard fans, once again, welcome back to the channel. Just going to open up with this little bit here. So we have a message here, we have a thing, and we have this bit here. Watch this bit. If I can get this to work. Yeah. It's often useful when you're writing stuff like this to get the devices to send you a message back. So listen to things, do stuff, and then reply. Let's see how we get on with that. So, this is where we are. Previously, we showed how to set up the ESP32, and off the back of the last video where I couldn't show you the menus, I now can. Incidentally, if anybody else is wondering how to do that, you need to capture the full screen and just remove bits from the screen that you don't want to show. Yeah, menus are separate windows or something apparently. So anyway, we come into here, we go into Preferences, and this is where we put in the text we had before. Again, I'll stick that in the description so it's there. And then we set up the ESP32, so we come up to here, which is this one, the Tools menu. We go into Board, which we come across here. We go into ESP32, and then, my God, there's lots of them. And let me just do that without the other port in the way. So boards ESP32, there's lots. Now the one I've gone for is this one. Sometimes some of the dev module ones work as well. W Rover can sometimes work. There's a lot of them, and like I said last time, that put me off a little bit. The normal boards you'd look at is Arduino, which is much easier. And down here we can set the CPU frequency. I just leave all of this at the default to start with. Yeah, it all does different things, but I don't worry about it too much. These machines are the 4 meg ones. Anyway, that's that. So that's where we left it. It's nice to look at. It's not terribly useful. So in this episode, what we're going to do is we are going to look at a feature that the ESP32 shares with an awful lot of these microcontrollers. In fact, I think all of them. It's got a serial port. Now, a serial port, for those who don't know, is where you send computer data, binary data, so just noughts and ones, and you send a naught, then you send a 1, then you send another 1, then you send a naught, then you send... Basically, you have a string of data, and you send it a single bit at a time at an agreed rate. So we're going to use that. We're going to use that to have the computer talk to this device, which is going to allow us to control these two little LEDs, just to show the principle of the thing. And yeah, let's have a look and see what we can do. Now for this one, we don't need any extra hardware. In fact, I'm going to use exactly the same hardware we have, which is, if I just jump into here, this. So this shows how I've wired up the extra LEDs. Now this, you may look at this and think, how the hell does that work? There's two LEDs. Surely they should both light up, and there's no current limiting resistor. And you'd be right, except for this line here. This is always going to be either at 0 volts or 3.3 volts. So if it's at 0, which is a low output, that means this little point here is at going to go, well, that means this point here goes to 0. So we're going to have 3 volts here. It's going to run down here, and it's going to go this way, and it's going to hit ground through this. This is a lower current path. It won't use it. And if this goes high, this bit here goes to 3.3. Well, there's going to be no current flow there. So it'll drop out here. So send the output high, the red LED comes on. Send the output low, the green LED comes on, with current either going that way or that way as we want it. And this time we're going to use this purple line, which is the serial port. So, yes. So that's what it's doing at the moment. We'll leave that little device to its own, and I've got no idea why that blurs when I change the screens. So what are we going to do? Well, the first thing we're going to do is get rid of that, because we don't need it. We do still need that, and we're going to add a new line up at the top here. We're going to go serial.begin and 115200. Okay, so what does that mean? Well, note the little dot in the middle and note the capital letter. Serial, if I hover over it, is a thing. It's actually defined as serial 0, which is it's an object. This is something that is set up for you in the first place. It is the first serial port. This programming language starts counting at 0, and it is a software object. Don't worry too much what that means. We're going to go into that later on, not in this video. And that object has multiple functions, one of which is called begin. And what you do is you can give it a whole load of parameters. We're only giving it one in this case, which is the speed I want it to talk at. So this is setting up to say I want this serial port to talk at 115,200 bits per second, which is quite fast. You can set them a lot lower than that. Some chips will go faster than that. That's a decent one, especially over this length here. There are reasons for using others, and all the rest of the parameters are just left at the default. So that's what that line there says. And if you were just using an Arduino, you'd finish it at that. We're not using an Arduino, we're using something a little bit faster. So what we actually need to do also is this, which is while okay, so what on earth is that doing? Well, while is a loop structure, and it says basically, I mean, actually, if I can probably make this a little bit more obvious. If I do that. So what this is saying is while whatever is in between those brackets evaluates as true, which in this case means any number that isn't 0. While that is true, do whatever's in here. Now the serial port will return a true value. It'll be a 0 if it's not working, and it'll be a 1, I think it is, if it is working. And that little exclamation mark inverts things. So what this is basically doing is saying, sorry, wrong bit, clicking on the wrong window. What that line's doing is saying, please switch the serial port on. What that line's doing is saying, while the serial port isn't ready, do what's between these brackets, which is nothing. So all that does is set the thing up and then wait for it to finish. Fairly straightforward. Now, these are, I mean, these words in purple, this is sort of like a language structure. While is a loop. There's another one where you can say do, which will... While puts the check at the beginning, do can put the check at the end, so you can always make sure you do something once and then never do it again. We're also going to come across other ones eventually, which is a loop called a for loop and an if statement, which we'll be coming on to in a minute. And that's its setup. As again, we still have our little pin mode here. And what I'm going to do, I'm going to come into this here, and I'm going to put in here digital write LED built in, which is our LED line, and I'm going to say that to go high. And this is just so that we start off with a known state. It will be in a state, but you don't necessarily know what until you've told it what to do. Different chips have different defaults, so I'm doing this way. Right, we're now set up, so we've now come into the loop, and what we need to do now is talk to this serial port. We'll come into exactly how we do it with the computer in a minute. But the command is this, serial.available greater than 0, and if it is, we're going to do something. Need to put the naught on the end of that as well, on the keyboard. So again, we're talking to this serial object, and this time we're calling a function it's got called available. Doesn't take any parameters, and it comes back with a number, and that number is the number of bytes of data, and a byte is 8 bits that are available to read. When I said this thing is transmitting at 115,200 bits per second, it's not quite as simple as divide that by 8 to get how many bytes, because you get all sorts of other bytes and bits and thingies in there as well. The beauty of this is you don't need to know about it. So these little bits are going to come along, they're going to come in, and when we've got at least 8 of them, which is a byte, this command will return 1 instead of 0. But if it returns 0, there's nothing ready for us. So what happens is we just ignore it. And that's fine. Now to start with, what we're going to do is we're going to read what we send to it and we're going to send it back. So what we need to do is define a little bit of memory space. Char is a character. It's a data type. In this case, it holds 8 bits of data, which is a byte, which is it's a single character. You can also define one uint8t, which would be... I could do it like that as well. Can't do both. We're going to do one or the other. They both store the same data. Calling it char, its character, is basically telling the compiler this is going to be a letter or a number of some sort, a printable character. What I'm going to do is say that equals serial.read. So again, we're talking to the serial port and we're saying read. Now what that function does is reads a single byte of data from the serial port and then tells the serial port, I've done this, please forget about it. So whatever was in there is now stored in the memory location that C references. And then what we're going to do is that. And that's saying to the serial port, call the function print, and it passes it that character. So basically this is going to say, read a character and send it back. So let's bring our little chip back up here and let's run this onto the device and we'll see what happens. Nothing the first time, so we'll try again. There's some fun and games with some of the buttons on this thing. That. Press that. There we go. Now we're uploading. And the first thing that happens is the red light comes on. And it's now sitting in this loop waiting for us to tell it something. So what we do is we come up to Tools and Serial Monitor. And what this does, this little window up at the bottom, 2 windows. In here we can type something and send it to the chip. So, let's type something in here. It doesn't do anything until I press enter. And it sends it, and then the chip does exactly what I've told it to. It sends it back. Well, okay. I mean, it could well be magic. So let's just modify this slightly. What we're going to do is say, right, we've got a character. So as soon as we get into here, I'm going to go digital write LED, finding the right character, built in. I'm going to say low. So as soon as we've got a character, it's going to turn the green LED on. Brilliant. And then it's going to send it back. And what we're going to do then is we're going to go delay 100. We're going to have a little bit of a pause. And then I'm going to turn the LED red again, like that. But I've got to put this in at the end as well. This is just so we can see it, because otherwise it'll flash red so quickly you can't see it and it'll pick the next character up. So what this should do now is type back a little bit slower. You remember the old teletypes you used to see when they were reading out the football results? It should be something like that. And the LED will flash, it'll change colour as it does each character, in theory. So we will try this. There we are, it's reset. So again, as you can see on screen, it's looking exactly the same as normal. Incidentally, I will at some point use the screen that's on these things. I'll do an episode on how to use them because they are quite nice. So here, send that and watch the screen. Oh, there you go. It's doing it character by character. not particularly useful, but it does show you what's happening. So there we go with that. And it works quite nicely. But it's still not that useful. I mean, we're reading data in, but we're not doing anything with it. So what I'm going to do is I'm going to get rid of all of that. And what we're now going to do is do a little bit of processing with the data. Wouldn't it be useful if we could tell this signal what aspect to show? And we can. So what we now do is we say if C, which remember is the character we've read in, if that equals a lowercase g, do something. The double equals sign is what's referred to as the equality operator. This is nothing to do with very modern politics. This is simply saying, is C the same as a lowercase g? Because we've read a character in, so is it the same as a lowercase g? If I just did that, oh, this is a very, very easy bug to do. What that does is say C now needs to equal g. That's an assignment operator. And that little snippet there, rather frustratingly, will return true because it's done it. And that means whatever's in this loop after will always run, which isn't usually what you want. So there we have that is equals. Now if that happens, we're going to do something. If that's not true, we're going to have an else if that says if C equals a lowercase r. The other thing to note here is these little single quotation marks. This is saying this is a character. If I did that, it's wrong, especially if I get rid of that. The double quotes tells you that is a text string. They're a little bit more of a pain to work with. So here we've got, if we've got a G, we're going to do this. Now, I could just do that. And what it'll say is, if it's a G, do this. And they'll carry on and go, oh, if it's an R, do this. Now, because obviously it can only be one or the other, or something else. But if I say else if, it says if it's a G, it'll do this, and then it will jump down here. But if it's not a G, it'll say, well, it's not a G, so what else could it be? Is it an R? We'll go into here. And then it'll drop out the bottom. So what we're going to do in here is we're going to say, well, actually, in this case, I want the light to be green. Tell right. Da, 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 da. Let's get this one right. LED built in low. And we know that will turn the green LED on. But what we actually want to do, we want to know what we're doing here. So I'm also going to do serial.write. And sorry, not write. I can do print. I'm going to do a different one here. Instead of just doing print, I'm going to do print ln. And what that is print a line of text and put a carriage return at the end of it. So if we've got a green signal, we can proceed. Otherwise, if we've told it we want a red signal, we need to tell it to stop. So we'll do LED built in. Finish typing it correctly. Hi, I'm looking at two different screens while I'm typing this. This is my excuse. Yeah. Print ln, and here I'm going to go stop, because when the signal's red, you mustn't go past it, or Leppy will come and bite you. I think, well, okay, so we've typed a G, we've typed an R. What happens if we type something else? Well, it executes the bit of code here instead, which is nothing. So it doesn't do anything. If we had a 3 aspect, so if we put a yellow LED in here, in that case they would have to be controlled differently. They'd have to have their own pins at that point. You could have a case here that says, oh, well, if C equals Y, turn that on. And you can do multiple things in here. As you can see, we've got these bits. So let's load this and let's see what it does. Again, I shall hold down this little boot button because that seems to be what it wants me to do. and let go in that, and it should pick it up. And again, we should start with a red signal. There we are, because we always start with a red signal. Now if I clear what I've got in there now, and if I now say green, signal goes green, and it says proceed. Red, stop. Yeah. Tell it hello, and it ignores it. Doesn't know what that means, so it doesn't do anything. Now you could modify the code so that it says if it's a G, go green. If it's anything else, go red. But I'm just leaving it at that at this point here. And we can do a few little bits here. I can go GGG, RRR, GGG, X, GGR. And send that. As you see, the lights flicker. And they flicker because these commands do take a little bit of time to do. And if I just do that and send that, again, you can sort of see a flicker. The red comes on very briefly and then it goes out because it just says on whatever we've set last time. Now this a little bit simpler than what we had last time, but this time we're just looking at some code and we're looking at a much more basic code. You could use this now to control a two-aspect signal on a model railway. In order to do it, you would need a computer sitting next to the thing on the end of a USB lead. So in future, we're going to look at how we can do this sort of stuff using, shall we say, do it over Wi-Fi or do it over something else. But for now, that's what we've got. So yeah, we'll look at this one. Now you could also say, I want another signal. I mean, because obviously this thing's got more pins. So maybe this ESP32 could control 2 signals. Well, what you do is you change this code to maybe it doesn't look at a single letter. It now looks at 2. And the first letter tells it what signal. So it would be 1. So you could type 1G. So signal 1 will go green. And you just basically nest a little loop in here. You say, well, if the signal's green, you then repeat this loop to say, what does this now do? Fairly straightforward. In fact, let's just do it, and then we'll be responding to 2 characters in a go. I wasn't going to do this, but I'm going to now. So if C equals spaces in, you don't have to put the spaces in, but it makes it easier to read. If the character equals 1, what we're going to do is this. Sorry, I'm going to just get rid of that. Right. There's a little trick. Need to do something else here. If the first character is equal to 1, what we need to do is see if we can read another one. So actually I'm going to leave that for this time, because that's... I was thinking that's going to be quite quick to do. It's not. It's a little bit more involved. So we're going to leave that at this point. Next time what we're going to do is look at, well, let's try adding a few other inputs. And we'll keep the same basic structure, but we'll say as well as the signalman in his box sending this G and this R, we'll add a sensor. And we'll say that sensor has also got to say you can proceed. So we can add a form of interlocking here. I mean, that could be anything. That could be a block detection sensor. It could be connected to a point. Maybe the point is in the wrong direction, so that no, you're not proceeding. So we'll have a little look at that time. Add a bit of logic to this. But in the meantime, that is the 3rd episode in this series. I hope that's slightly more useful. I will put those links to setting the ESP32 up in the description again. And in the meanwhile, I will leave you to the rest of your day. I hope you have a very good day, and I will see you all in the next one. Thank you very much, and goodbye.